Okay, let's start. Hello, everyone. Thank you for joining this workshop today. I'm Patrick from Tributech, and also my colleague Maximilian joined today, which was one of our lead developer and also expert in the area of digital twins. And today we want to give you an introduction in digital twins in general, just a really short overview and what we are working on at Tributech with digital twins. So let me share my presentation and please let me know if you can see the slides.
Yes, we can see.
Fine, perfect. So first, we just want to give a little context what a digital twin is in general from our perspective, just to give a little bit context, because there are many different solutions out there and also many different views on digital twins. Then we want to introduce new digital twin standards, where we have also selected one of these standards for our technology, and also present the technology stack that we have developed. And at the end, we will also present some use cases where we are currently using or our customers are using our digital twin stack in projects. And we will end the presentation with a short live demonstration. And then we will also have time to ask questions. Please feel also free to put questions in the meantime in the chat so that we can look for potential questions afterwards. And I will give you also a short overview how you can potentially use our digital twin tech stack within the InterQ project. Okay, so let's get started. So what is a digital twin in general? From our point of view, a digital twin is like a digital clone, a digital representation of an asset, process, or any other thing that is connected to the digital world. So it represents the current state of some kind like device, machine, some process, and twins can be used to standardize operations and introduce a common and business-specific vocabulary. And the twins should also reflect all the changes that are made in the physical world, or also when you adopt changes in the digital world that get synchronized with the asset in both directions. And once we have that digital representation, we can also put different applications on top. You may know that there are many applications out there that run digital twin simulations where you can set some parameters and optimize your product development process, or run some simulations with parameters out there. But there are also many other potential applications to automate actions or optimize things. And we will divide it in general in three areas. So on the one side, we have the thing that is represented as a digital twin, where we have this digital representation that holds the current state of the asset, product, or process. And we have applications that are sitting on top of this digital twin, interacting with the current state, or also updating the current state and providing new parameters to the asset itself, for example. And a digital twin can represent nearly everything. So a digital twin can represent just a part, a whole asset like a pump, or a whole system like a car, or a whole factory, or even a whole building. Or it can also represent some kind of process. So in general, there are no limits what a twin can represent. In general, the most industry needs some kind of domain-specific vocabulary to be able to describe the things as a digital twin. And if we look at the digital twin solutions out there, what we have today, we see some limitations. So these solutions have a great value in their area where they're offering some kind of application for simulations or something like that. But the most applications are limited to that specific scope of running a simulation for a specific product, and they cannot cover. Sorry. No problem. And they cannot cover a broader view which goes beyond just a single asset or the twin of some machine to also cover other elements of the product lifecycle or value chain. In addition, there are no standards in the most systems, and it's hard to create the interoperability between the different applications and systems, especially when you need data from different stations along the value chain or for different data sources. It's hard to have that interoperability in place. And for the new standards that are upcoming now, there is also very limited tooling. And for newcomers, all these new technologies are really hard to integrate, and you need to build up a huge amount of expert knowledge to be able to introduce these digital twin technologies into your existing applications and systems. And this is also the starting point where we have researched different digital twin standards, and we thought about how can we implement digital twin technologies into our software platform. So we at Tributech, we are offering in general a data sharing and IoT integration platform. And in InterQ, we are part of work package 6, where we are also responsible for the data sharing. And over the last 1.5 years, we have developed our own open source digital twin stack. And my colleague Max will give you now an introduction about the concept behind, about the standards, and what we have built so far.
Thank you, Patrick. I think I will take the screen over from you.
Okay, that's fine.
Okay. When we talk about digital twins, we should first of all talk about the standards when it comes to the technical implementations of digital twins. At the moment, there are there's quite a lot of competition going on in that area. There's a project from Mozilla called Web of Things that basically focuses on the whole stack. So they also try to support interoperability via web interfaces immediately within the standard. And then we have other standards that more or less focus on the describing of digital twins and are more like a markup language. One of these projects is the Asset Administration Shell, and that's a project from Germany, and is kind of used a lot when it comes to automotive industry. And then there's a standard from Microsoft that's called the Digital Twin Definition Language Standard that basically also allows you to describe digital twins. All of these standards have some differences between them. So some of them allow you to basically describe relationships between entities, and some of them don't. So you have some different building blocks and properties that you can use depending on what standard you use. For our product, we decided to use the Digital Twin Definition Language Standard because of some options that are not available in other standards, like the thing with the relationships. So basically, we want to be able to say that we have, for example, a car, and this car consists out of a motor, some wheels, some seats and windows and stuff like that. When we talk about the language, we mean the building blocks, and then we also need to basically describe a vocabulary that can be used to describe these elements like a motor. Yes. So On the right side, you can see some examples of this. For example, the data asset twins are the twins that we use to describe the devices that we can configure within our digital twin stack using the Tributech dataspace kit. Then we have the Gaia-X self-descriptions that can be used to describe Gaia-X entities. And then there's also the example of the real estate core that's basically from Microsoft and allows you to describe buildings and smart cities. The digital twin stack, the motivation for it basically was to be able to have a layer that allows us to connect devices to data or to context. So we have, for example, data streams that get produced on a device, and then we want to attach some data to that data stream. So that was our initial goal with the digital twin stack. And while we were realizing that goal, we noticed that we can basically standardize a lot of our operations and developments using a common language. Because the language is common and shared among all our business applications, we also noticed that we can build user-friendly tooling to implement digital twins and visualize them. And combining all those together, it's possible to basically connect different systems together. So for example, we have an existing system from a customer. They use an existing tool to manage some data. And now they want to get some real-time data from devices. So using the digital twin stack, they basically can combine those two things together. When it comes to the Tributech digital twin stack, we generally talk about two different kinds of digital twins. First of all, we have the core twins. So core twins are like twins that have a meaning within our system. For example, we know what a device is and what a device should be able to do. But the customer might say, okay, for me, this is not a device, but for me, this is like assembly line. So the customer would like to use the term assembly line, but for us, it's a device. So in this case, the customer could go and create an application twin, and this application twin could build upon one of our core twins. So that's the general line that we say, okay, these are the two differences that you have as options, and all the core twins have a meaning within our system. So if you, for example, have a twin that uses one of these core twins and you change a property there, this will have an impact within our system. So for example, the persistence options will change. So we write it to a different database. All things that are changed within an application twin are more or less the responsibility of the customer. So for example, if he changes the property, we just store it, but we don't adapt any logic based on that change from the customer. With our current digital twin stack, we already implemented quite a lot of features. So for example, the first one is the catalog service. Using the catalog service, we are able to create meta models for these digital twins. A meta model is basically the description, what property does this twin have available, out of what components does it consist of, what relationships does it have, what relationships are possible, and so on. And we have a graphical UI that allows us to manage those, to create new versions, to extend them, and so on. Out of such a meta model, we can then also create an instance. And an instance is basically, in our case, just a JSON representation of this digital twin. So we can take the meta model and then we generate a form out of it, and then we can edit that form and store the twin instances. That's really useful if you just want to quickly prototype something or you want to adapt something manually. The next feature is the model workspace, where we can basically visualize how a twin could look like. So what are all the options it does have, with what it is connected, and how it interacts more or less with other models. So we can say this model extends from one of our core models, and it has two different children that can be connected to it, for example. The same also works for the twins themselves. So we can say, for example, again, to our car example, we have a car, and this car has a motor. The motor has some moving parts in it, and then we could create the digital representation out of that. And then we could take that representation and visualize the whole graph as a whole using our tooling. And yeah, there's also the possibility to just go into the system and check what digital twins are available at the moment and visualize them. When we look at the tech stack for this, we can see that we have our digital twin open source services on the left side. Basically the model catalog, as I mentioned before, for storing those meta models, and the twin API for storing the actual data. So for example, the car is red would be in the twin API, if we take that as an example. And this open source stack is also connected to our enterprise services. So all the enterprise services are using the open source stack for data management when it comes to metadata. Here we can see how this UI looks like. So in this case, we have the twin workspace, where we can use the UI to create a graphical representation of a device in our case. So we can see we have a steel factory here that has some source, and that source has some values that get produced. Usually this would be quite hard to make generic, but because we are using digital twins, we can easily extend sources or create new sources and just add the additional logic that we need for a certain source, but can still use all the logic that we initially implemented, because it's all compatible, because it all uses the same model underneath. And on the right side, we can see the form that is automatically generated out of this digital twin meta model representation, where we can then edit the properties to make some adaptations, or in our case, to configure a device. And in the background, we can see the representation, how this twin looks like as a graph. And here we can see the model workspace. So on the left side, all the known models from a certain ecosystem, in our case, are shown. So a model is this meta model representation, and we can see that we have the option to have certain properties on it. We have some relationships. We can also have complex properties that are used within the properties, relationships, and other types. We can also see the JSON representation, how the final model looks like, written in the digital twin definition language in this case. And we can modify the model using the form again. So overall, the benefits of the Tributech digital twin stack are that we create a generic context layer for all applications. So like I mentioned before, the customer has an existing system. We create a new system. We want to connect them somehow together, or we want to enhance the data that the customer already has. So we create digital twins out of them, and then we can work with these digital twins again in our system, add relationships to them, and add additional data. Because the models also know what is possible, we can also create certain business rules. So for example, you can't attach, I don't know, a jet turbine to a car or something like that. So we can limit what is possible with certain twins based on the data model that the twin consists out of. We can standardize our applications. So we already use this quite a lot. So everything is based on the generic base classes in our application. And we implement the logic once, and when something changes, we just add on a certain twin representation for the different kind, and then only handle the additional logic when needed while reusing the old logic. And that's completely generic. Yeah, like I mentioned, interoperability, I already mentioned before. We can generate the visualizations that we saw before. Also, additional visualizations would be possible because the models are there. It's just how you visualize them in general. And yeah, it's very easy to use because the model and the actual representation are separated. So we have an option to always validate a certain twin based on its model or based on the meta model. And this way, it's very easy to work with the normal JSON models without having all the complexity that is usually associated with digital twin, like linked data. That is used for most of the other standards. Everything I talked about is open source on GitHub. The links are in the presentation. I think we will share that later. And now I give back to Patrick to show you some use case examples.
Perfect. Thanks, Max. I will share my screen again. Okay, let's go to the use cases. We have prepared 3 examples. And the first example is how we use digital twins for IoT devices. And here we see the general architecture of our IoT platform stack, where we have a local IoT edge device, which has some kind of device management, where you can install the different Docker services to integrate data sources of your OPC UA server, or what protocol you are using. We have there a message broker, and we have the software services that then sends the data to the backend and so on. And all the core components are included in our software-based agents that can be integrated into different IoT devices. And this agent also contains the digital twin. So the whole configuration of that IoT device is built up on the digital twin stack, and all configuration options are available through this digital twin configuration. We have an additional application that can be installed on Windows and macOS, where system integrators can configure new IoT devices and can create the individual configuration that also includes all the mapping configuration and so on, which is really easy and flexible. And this twin gets then also updated with the backend. So once I set the twin configuration on the device, it will also automatically provide the state to the backend. And we have also the current state and the virtual representation of the IoT device and all of its configuration in the backend available. And currently, we're also working on enabling a two-way communication so that we can also update the twin on the backend side, and the IoT device automatically adapts the changes to the asset itself. As we have already seen before, here we see the digital twin, which contains all the configurations of such an IoT device. And this is an configuration example of an IoT device which contains different temperature and pressure data streams, where we have different configuration options per stream. For example, OPC UA, where we can also define namespace and identifier and so on. And we also have available many different other sources which are part of our digital twin vocabulary for that IoT devices. So it's really easy for us to maintain many different sets of configuration, and we really have a huge reduction of the overall complexity of configuring different IoT devices. And we also have always an actual representation, which we can also use for building up visualizations on that structure and so on. A second use case, which is also part of our platform is that we're also using our digital twin stack for the data management. So we have different data layers in our system, also with different databases, and you basically can select where a data stream can be stored or should be available on the message bus, should be exported to additional external tools like Azure Data Lake, for example. And on the level of a data stream, we can also attach additional twin properties as a configuration, which will be then adopted from different backend services that are responsible for managing the data. So if we look again in the twin workspace, we see here one data stream, the air temperature, which has attached additional twins with configuration options for the data management, where we can define properties like, is this data stream published to a message bus or exported to another system? And that's also really unifying and making that configurations more simple and more standardized. And it can also be easier automated because everything can also be managed through the APIs. And the third use case we have prepared for today is a more future-oriented use case. We call it the digital twin for product passport. And if you think about the whole product lifecycle, you have many different questions and insights that you want to have answered. Like, for example, what is the current health state of my product? What is the CO2 footprint? How efficiently was it used, and so on. And all these questions are tackling different kinds of data that needs to be analyzed. And this data is not only within a single system, it's across many different systems typically, and it's also across different stakeholders along the value chain, because some data is at the supplier, some data at the manufacturer, and other data is at the user. And the huge challenge in that is to provide and layer across all that different data sources. And if we look at such a life cycle, we have involved the different stakeholders with their different data sources. So from the supplier to the recycler, and everyone has stored some kind of data. And if you want to have that insights based on a product level, you need to put all the different data sources in context. And this is also where the digital twin stack comes into place, which enables this contextualization about all the different data sources, so that you have a single source of truth that points to all the different data sources and enables you to analyze these different kinds of data in the context of a single produced part, for example. We are currently working on that use case with different customers. So our stack is the baseline for defining the data models of a product, for example, and to provide the context layer. And our customers then build different kind of applications on top to analyze the current CO2 footprint, for example, or to evaluate the health state of the product. And if you're starting with creating a product wallet, there are many different opportunities what you can build on top. Here are just some examples, and that's really a huge use case. So the most companies are deciding to focus on one aspect, like, for example, the CO2 footprint, and to start with this use case and build an application on top of the digital twin stack. What is also really interesting, maybe you have heard about that, the EU is also planning to introduce regulations regarding a digital product passport, which is really focused on sustainability and also the circular economy, that we have a more sustainable value chain and a better reuse of all the different materials. And in some industries, like, for example, the battery system of electric vehicles, they are really close to having the first regulations in place, which will really enforce the manufacturers to collect that data along the value chain and to document a product passport, where you need to document what are the materials that the battery consists of, what is the CO2 footprint, what is the current health state, and so on. And there will be different steps. It will start with a simple product passport, which only introduces some static information for each product, but they also have the plans to include more dynamic information and also to include the usage data as a further requirement to enforce more sustainability and more reuse of the different materials. Yeah, so in the next steps, we would go into a short live demonstration. Here I want to take a short break and ask you if you have any questions so far to the presentation of the stack of the use cases or something else. Please feel free to ask. Anybody has some questions? Or is everything clear? Okay, then I will continue with the live demonstration and then we can go again back to the questions. Can you see my screen? With the web interface?
Yeah.
Okay, perfect. So before we have talked about our twin stack, which has different vocabularies to describe, for example, digital twin configurations or how what parts can have a car, for example. And here we see all the data models of our platform stack. And there we have already a huge number of different data models where we see, okay, our system supports, sorry, that was not what I wanted. Our system supports data sources and there are different types of data sources. So we have, for example, a simulated source, an OPC-UA source, and so on. And this is basically the vocabulary. If we exclude the annotations, it's a bit simpler. And that's all the different data models that are available where I can build a digital twin instance. So based on that, I can really create this instance, this virtual representation of my assets and to fill it with all the specific properties of a single device or a single product. And to create such a digital twin, we have different tools where we have a twin workspace available where we can create these twin instances. In this case, this is our configuration tool for IoT devices where we are currently connected with an IoT edge device. And in the configuration tab, we have that twin workspace. If we delete the current configuration, we can start from scratch and we can add an edge device. And then we can select, okay, our edge device has an OPC-UA data source and it also has OPC-UA data streams. And so we can build up the digital twin of our IoT device, which then also is used to adapt all the configurations to the IoT device, where we can define in the end the mapping to collect the different data. If we have a second data source, we can also add MQTT as a data source and add MQTT data streams to it. And therefore, we can build individual configurations for each IoT device based on that requirements. without the need to implement anything specific for the device, because the configuration management is really generic, built up on the digital twin stack. And once we apply that to the device, the dataset will also be automatically generated in the backend. I will now load the current twin from the IoT device again, where we have that simulated sensor with different data points, like this converter temperature and converter pressure and so on. And this dataset also exists already in our backend. So if we go back to the backend dashboard to the datasets, we can also look for this test dataset, and it is this one, and there we see also the different kinds of data streams. And all you see here is provisioned automatically. So once we have the twin, all the system is really spinning up itself, and we do not take any further actions. Also, the visualizations are generated automatically based on that twin information. And we can then also view the live data and all the properties on top of that. And here we also have the persistence and publish options, which are also based on the digital twin configuration. And we can also go to the Stream Explorer and look for edge devices. And we have then a list of all the edge devices and their twins, which are available on the backend side. And we can also, again, look at this digital twin and see then the different data sources and data streams that are in our system. So, and this is the part of generating twin instances, which we are currently using for really, we can say, a simple use case like IoT device configuration, but we really have huge benefits in the standardization, in the generation of visualization, and also in the management of different configurations. And for the experts, we also have an additional interface where you can also create your own data models with an editor. So here we see the data models that are used to create the digital twin instances. And there you also have the possibility to add new data models and to define everything in this comfortable tooling. In addition to the UIs, you also have the REST APIs where you can directly interact with the catalog service, and you can also interact with the twin service where you can also automate all these actions with your own applications on top. As mentioned by Max, all these stuff is available open source on GitHub, where we also have the catalog API and the twin API service available. And we also have the vocabulary from our own digital twins open source available, where you can also view all the open source DTDL models that are included in our catalog. Yeah, so that was a short live demonstration of our system. So please provide your questions.